Alright guys, so today we're going to do the problem of the day for December 16th. It is called implementing queue using stacks. It says implement a first in first out queue using only 2 stacks. The implemented queue should support all the functions of a normal queue. And it says implement myQueue class, void push, yada yada, pop, peek, empty. You must use only standard operations of a stack, which means only push to top, peek from top, size, and is empty operations, which are valid. Depending on your language, the stack may not be supported natively. You may stimulate a stack using a list or a deck as long as you use only a stack's standard operations. Okay. Now, okay, so stack is first in, first out. Last in, first out. This and a queue is first in, first out. So, as always, let's talk about our goal. Make a queue using only 2 stacks. Inputs. We have a push call. We have a pop call, peek call, and an empty call. Okay, output, return results for each function call. Okay. So let's go ahead and analyze what a queue would look like. Let's say I start inserting some numbers 1 to 5 into my queue. When I pop, I should return 1. And when I peek, I should return a 2, pop 2, pop 3, peek, I should return a 4, insert 6, pop 5, pop 6, something like that. So I'm always accessing this, the first foremost element. So for a stack, that is going to be a little more tricky. So implementing a queue using stacks. So when I do 1, 2, 3, 4, 5, when I say pop, it'll pop the 5th element since that was the last entered element. What I really want is to pop the first element, which is 1. So the brute force solution right now is, let's say these are my 2 stacks, right? And I insert all these numbers in, and now I want to pop. So what do I need to do? I need to reach all the way into 1 while saving all these other elements 2 to 5. So I'm going to pop the 5 and put it into the second stack. 4, 3, 2, 1. So now this stack is empty. And now I can, using stack pop this element, return it, pop 1. Now, the question is do I need to return this stack and reverse it, right? So let's go, I can pop again, I'll pop a 2, that's great. Now what happens when I insert a 10? So if I insert a 10, and then I pop again, I'll pop 3, pop 4, pop 5, so that empties this. And then now that this is empty, I need to see if I have any more in my first stack. So that's what needs to happen. My insertion keeps going in this stack no matter what happens. But the moment I need a peek or pop, I need to reverse everything in this first stack into the second, and then so on. I hope that makes sense, that explanation. I was just trying to work through an example. So 1, 2, 3, and then 3, 2, 1. Now I pop 1. Yada yada, and I can check, is it empty? I check both stacks to see if it's empty, and then return that. Okay, so we have our, let's call this the push stack, and we'll call this the pop stack. Okay, when we push, we just simply push stack append x. Pop, we will if pop stack, if not pop stack. So I'm saying if there's nothing in the pop stack, then let's go ahead and start popping things out of the push stack. So let's see. All the calls to pop and peek are valid, so that's very important. I won't need a case where I'm trying to pop in a stack that doesn't have anything in it. Pop stack append push stack pop, and then otherwise, then we'll say return pop stack pop. Peek, same thing. We're going to empty our array here and say return pop stack -1. Return length of pop stack, oops, not poop, is equal to 0, and length of push stack is equal to 0. Okay, so let's go ahead and run through this example. Let's say I push a 1 and then a 2 and I say peek. Now, when I go to peek, my pop stack is currently empty, so I empty the push stack and then I pinned it onto the pop stack. So now it's reversed. In the pop stack, it's 2, 1. Now I give you the last element of that pop stack, which will be, it looks like 2, 1. So that means I will return you the 1. And that's how you peek. The same thing for the pop. I check if the pop stack's empty. If it's not, that means I've already gotten the last elements of the queue, and then I can kind of just pop you that element. Now I can keep pushing elements onto the queue and I won't be affected because I still have elements to pop. And yeah. Now the time complexities for each of these functions, I guess I'll write it here. For the peek, for the push, it'll always be O of 1. For the pop, worst case is O of n, but amortized, for the most part, I guess you can say amortized O of 1. For the most part, well, not really amortized, because I mean, the best case scenario is that you pushed a lot of elements onto, or we pushed a lot of elements onto the stack, and then we kind of just shoved them into the pop stack all at once. So for the most part, it's O of 1. Same thing for the peek. It's going to be O of n, generally amortized O of 1. And the empty call is going to be O of 1. Okay, so if we run this, well, of course, let's come up with some more cases here. So push, peek, pop, empty. Let's push another one, and then let's check if it's, let's pop and make sure that it's correct. So empty, push a 3, and then pop. Okay, these two cases. Push stack is not defined. Ah, I forgot. In Python, we have to use the self. Okay. And I forgot to do it here. Okay. So yeah. So can you implement the queue such that each operation is amortized O of 1 time complexity? In other words, performing n operations will take overall O of n time, even if one of those operations may take longer. Yeah, So this is amortize of 1. So this should be the answer. We submit this real quick. And granted, we didn't miss any specific cases. This is the correct answer. So let's take a look at the solutions to make sure that I haven't missed anything. Let's go ahead with votes. Short O1 amortized. So one input stack, push, and one output stack to peak pop. Input to output when needed. When I need a peak pop, but the output stack is empty. When that happens, I move all elements. Therefore, correct. So this is amortize of 1 if I have it correct. All right, cool. So, oh, let me fix the back button. Okay. Cool. So that's how you do it in Python. I think I'm going to go ahead and end the video for today. I don't think needing to do this in C++. It's a fairly trivial implementation, but what can be tricky is reaching how to do this using 2 stacks. All right, I hope you enjoyed the video. Please leave a comment below. Tell me what you think. Tell me what needs to be improved. And thank you for watching.